We're here with Trimble's all-new R12i GNSS receiver. The R12i incorporates a whole new technology from Trimble called TIP technology. Now what TIP stands for is Trimble Inertial Platform. This platform provides inertial-based tilt compensation positioning. What this means is that the receiver is constantly calculating the tip position of the survey rod. We can now take tilted measurements. The R12i also harnesses a new technology from Trimble called the ProPoint engine. In the real world, that means that we can get into positions that we haven't been able to get into before. We can get shots closer to buildings in harsher environments such as under or near trees, giving us faster and more reliable positions. The R12i receiver is supported on the latest versions of Trimble Access, which can operate on the TSC7 and Trimble's tablets such as the T10 and T7. It's also supported on the TDC600 Android platform. We can see here on Trimble Access that IMU tilt compensation is enabled and is functioning. On Trimble Access there are three things that show us this. In the top right hand corner we can see that RTK and IMU is enabled. Just along to the left of that there's a distinctive icon showing the tilt compensation icon. It's a receiver showing the motion. The third thing that we can look out for is on the map. Our position is shown with an arrow. This is showing our heading. This also indicates that we are in IMU tilt compensation mode. Most surveyors are going to use tilt compensation mode for the majority of surveying that they do. 90–95% if not more. It really is reliable, faster, more efficient, and it's the new way that surveying is going to be done. Should you choose to turn the IMU tilt compensation off, the process is quite simple. Within Trimble Access you go to the icon at the top of the status bar, tap that and that'll open the GNSS functions. To turn the IMU tilt compensation off, simply tap that button. We can see that the screen has changed. The icon at the top is now a single receiver. This indicates that it's in GNSS mode only. We can see that it takes a few seconds to reinitialize, but as soon as the initialization has been gained, you'll see the green check mark to show that you are good to go. For most situations, the surveyor is going to be in the IMU tilt compensation mode. So there's very little chance that you're going to need to use this, and it's certainly not going to be a frequent task that you undertake. The process to turn IMU tilt compensation back on is very similar to what we just undertook. We go to the icon at the top of the status bar and open the GNSS functions. We go to IMU tilt compensation and that will turn it on. What we see is that we need to get alignment. We also see a change of the icon indicating that we are in IMU tilt compensation mode. The important thing here is the alignment, and that's what we need to gain before we can continue on with our survey and get the green check marks that we're after. There are a couple of ways to do this. You can stay stationary and simply move the receiver around. This should be enough to get the alignment that we need for the IMU. The other method is simply to walk around. Again, this is providing movement and motion for the IMU. If you're out in the field surveying, by the time you've walked to the next point, this should be in alignment and the system should be ready to take observations. While starting a survey, you'll see that there's a message saying Face LED Panel. What that means is that the lights on the receiver, this LED panel here, needs to be facing you, the surveyor. The reason the LED panel needs to face the surveyor at all times is for the orientation and heading information that you're provided with in Trimble Access. Whether that be the icon on the map that we see, currently here showing me facing west, or whether it be, for example, staking out. The directions that you are provided there are based on the orientation of the receiver, and that orientation is determined by the LED panel. The LED panel needs to be facing you, the surveyor, at all times. When using the R12i in tilt compensation mode, the workflows within Trimble Access are still the same, whether you're measuring a point as a topo or whether you're staking out. The workflows are still the same. The only difference is you're now able to tilt. This allows us to pay attention to what we're doing in terms of picking up the position and the precisions that we're observing at the time of the survey. Another thing to point out is the error estimates that we see in Trimble Access. They are a combination of both the GNSS position that you have and the IMU tilt compensation. Trimble Access provides full data traceability for each observation that is taken. To check the data relating to each observation, there are a couple of methods. You can either review the point through Review Job or go to Point Manager. To review the data for a certain point using Review Job, go Control R, click on the icon next to it to expand the information, go to Quality Control and check out the information pertaining to that observation. You've got device orientation. You also have quality control information, QC1 and QC2. Another way of getting to that is going through the Point Manager. It's the same process. You expand the information on that observation you've taken, go to the quality control and find the information related to that position you've just observed. The other way that you can check all this information is through Trimble Business Center back in the office. So the R12i is great for topo. It opens up a whole new way of doing these surveys that we do and a different way of taking observations. Within Trimble Access, it's still the same as it always has been. We either take a topo point, which takes multiple observations, so we'd set an amount of time, or a rapid point. For the sake of this, I'm just going to take rapid points. As we know in the past, what we've had to do is set up on a point, get the rod level, and take the observation. The glory of the R12i is we don't need to worry about this bubble. It's all about where the tip of the rod is. That allows us to get points we've never been able to get before, such as this location here. It also significantly speeds up our workflow as we don't need to worry about this level. So simply putting the rod down, taking the shot, paying attention to where that is all we need to be doing.
Observation stored. Observation stored. Observation stored. Observation stored. Observation stored.
Another common workflow for the surveyor out doing a topo is picking up features. So the likes of this bank would be an important one to get the elevations. So let's just run through the top and the bottom of this bank. We'll show you how quick it is, how easy, and just how efficient it is with the R12i to get these observations. So starting with the bottom, typically, as we were saying, we'd have to level up. Here, we don't need to be paying attention to the level. We can take that shot. It means a lot less movement in the field for the surveyor, a lot less thinking, and a significant time saving with the ability to move faster through the shots.
Observation stored. Observation stored. Observation stored.
It also simplifies it because surveyors only need to pay attention to the tip of the rod, but also that frees up time and the ability to look at the precisions on screen. So the surveyor can pay attention to what's important. Instead of watching this level bubble, we just need to pay attention to what we're observing and our precisions. Another common workflow, and what's been a challenge for surveyors in the past, is picking up the likes of centerline of a bush or something that's difficult to observe. Could even be the likes of a manhole where you can't get that invert. But traditionally, this is a shot that's been very difficult for a surveyor to pick up. We'd often have to do the likes of ties and offsets to it, but now with the R12i, its ability to tilt, but also the ability to get difficult shots in harsh environments, we can pick up the centerline of this bush.
Observation stored.
So in the past, it's something we wouldn't have been able to do, certainly not with the GNSS. We're seeing here really good precisions. We're looking in the millimeter range, currently around about 14 millimeters, both horizontal and vertical, which is very acceptable for a point like this. We'll pick up another one in this area here. And again, in this thick environment, we're seeing 14 millimeters, 15 millimeters vertically, 19 millimeters horizontally. Really impressive. And that's down to the ProPoint engine that's in the R12i. The reason we're able to get the center line of the bush is because of the tip technology, the inertial platform to get that tilted measurement. So the combination of those two technologies are allowing us to do things that we've never done before, significantly changing the way that we work and also improving our efficiency in the field. If we look around at what we're surveying here, getting shots like this have actually been near impossible in the past. We can see a very, very large coniferous tree here. We're also got a building to our east, and this is thick green canopy as well. ProPoint engine shines in these conditions. It allows us to get shots we've never got before. Combined with the tilt capabilities of the R12i, we can access shots that we've never been able to either. Another really good example for a surveyor of something that's been difficult, if not impossible to pick up in the past, is a building corner, particularly with a GNSS system. Reasons for that: obviously it's inaccessible, we can't get level over the building corner. Also, the likes of this building here being tall, we have no access to the satellites in the sky, so getting a position is difficult. With the ProPoint engine, we're allowed or able to get those positions far better than anything we've ever been able to do before. And with the tilt, we can also get in to get that building corner. So let's pick up this corner as an example. Again, all we're concentrating on here is the position of the tip of the rod. We can see that our residuals are good, they're coming down here. And we can take a shot. That easy. In the past, it has almost literally been impossible, using a GNSS system at least. We would have had to set control and come back with a total station, or we'd have to set a couple of points and take ties to the building corner. This way we can actually pick up accurately, both horizontally and vertically, the position that we're needing. Another good example is picking up a point that's in the past difficult to even reach, so a surveyor can't get up and they can't see the level bubble.
Observation stored.
But just that easy to pick it up. Another one is an internal corner, even more difficult, and even with the total station that's difficult to get. It would require a specific setup, but with the R12i, once again, because we can just put the tip of the rod where we need to take the observation, we can get this receiver out into the satellites and get a good position. We can take the observation. It's just that easy. It's changed how we survey as a surveyor. We can pick up these points that we've never been able to in the past. Here is one more example of something that's never been possible for a surveyor before, that the R12i with the ProPoint engine and tip technology is now allowing us to do. The likes of this water valve partway up a wall typically would be impossible to get. We'd have to take offsets or shoot it with the total station. Let's see how this goes. Just looking at our precisions here, we'd confidently take a shot. It's within our tolerances, so let's do just that.
Observation stored.
And that to me is amazing. It's something that we've never been able to do before as a surveyor. It saves us a huge amount of times instead of having to come back and set up that total station. Just for the heck of it, let's see how this R12i performs as we go down. We can see here we're 38 millimeters by 20 millimeters precisions. Continuing to go down here, we can see that our precisions are degrading, but that's as we'd expect. We're actually losing a lot of the sky in terms of satellites that we can pick up. Bear in mind we've also got this wall here beside us, and here we are almost horizontal. We're 23 millimeters in the vertical, 40 in the horizontal. It's about as far as my arm will reach, so let's take a shot.
Observation stored.
That's incredible, it's unbelievable. We see there horizontal around about that 40, vertical around the 20 or better. We do see that the position is degrading, which is primarily due to the fact that we're losing satellites in the sky for the GNSS solution that we're trying to achieve. The IMU, as we just saw, continues to work and does a very impressive job of it. A combination of the tip technology and Trimble's ProPoint GNSS positioning solution have been an absolute game changer in this R12i. It's an entirely new way of surveying. Stakeout with the all-new R12i is a completely new process, and in my opinion it's one of the greatest new features of this system. Along with Trimble Access, it's a completely different way of working in the field for the surveyor. The old process was very much a step-by-step, iterative approach of getting closer, getting level, checking your numbers, see where you need to go. Now though, it's simplified, significantly simplified, and it's a direct approach for staking out. All we need to be doing is watching the map, where you'll see the target of where we're going and our position. And all we want to do is line up the position on the map with the target, and you'll be right on the point, first time, every time. So let's stake out a point that we've got here. You can see we're getting close, and as we get closer it pans in. And it's as simple as watching that map and lining up the positions. First time without any effort, we're sub-centimetre straight onto the point. Show you how easy it is, we'll stake out another one. We've got point number 203. Again, because we've got the receiver and the LED lights aligned to us, it's using our position in that heading. We start by following the arrow, it's showing me this way. I start walking. As soon as I get closer, it zooms into that map view showing me and the target. And all we need to do is align those two. First time within millimeters. Still. Got a control point over here, point number 200. We'll stake that out. Same process. Again, looking at the screen, using the tip as guidance. We don't even need to be looking at the tip though. The tip is what the position is, but it's what we're seeing on screen visually. We can see instantly, millimeters. The R12i is available today. Contact your local Trimble distributor if you want a demo or if you're ready to buy.